This is Unit 1 lecture over lab safety and scientific method. So there's going to be different safety symbols that are going to be on chemicals in the classroom or in the laboratory. So you need to be able to identify the symbol and what it means and what you should do or not do around them. The first one looks like a skeleton or a skull face. This is a toxic symbol. This means that if you ingest it or you drink it, you put it in your mouth, it can either cause you to be very sick or it can cause death. So do not put anything in your mouth that has this symbol. The next one is radioactive. This is placed on either rooms that contain radioactive materials or it can be placed on the actual chemical itself. But these emit radioactive particles and it can cause you to be very sick if you don't have the appropriate personal protective equipment on, or it can cause even death after a certain amount of time being exposed to the radioactive material. The next symbol has a flame. This is a flammable symbol. That means it can easily catch on fire, so you do not want to have anything with a flame near an open fire, an electrical socket, a hot plate, or anything that can cause heat or any flame, because it will catch on fire, and that is very, very, very dangerous. The symbol with the X, this is an irritant, and it sounds exactly as it says. It will irritate you for days at a time if you get it on your skin and you don't wash it off right away. If you get something on your skin that has this X symbol, it will itch, bug you, scratch you, just cause a lot of irritation, maybe even turn your skin a little bit red. So if you get something on your skin with this symbol, please go to the wash station and wash your hand, arm, whatever part with as much soap and water as you can. Flush it for at least 10 to 15 minutes. The next one is a corrosive symbol, and if you get something corrosive on you or on the table, it will cause you to corrode or break down. If you look at the tabletop and the hand, there's like a little small indentation that goes down. That means it will break down your skin or break down the table, and that is very dangerous because you really don't want something eating through your skin. The first one on the bottom, this is a biohazard symbol, and this is where you put chemicals or substances of bodily fluids like blood samples or getting urine samples or gloves or anything that touches the body that can spread different diseases. You want to have this symbol placed on those containers. And that's especially important in the health science world because you don't want to put your hand in a trash can full of needles or injection or any of that, because you could break your finger and then you have someone else's blood inside of your body. That is very dangerous, so you need to stay away from any container that has the biohazard symbol next to it. That second symbol, this is explosive. Sounds as what it says. It will explode given the correct environmental factors. So you do not want to mess around with different explosive type chemicals at any time, not even with the teacher's permission, because I will not give you permission to work with those types of chemicals. Just be very aware of those chemicals around you, and again, stay away. This next symbol here with a little fish upside down, this is environmental hazards, and if exposed to the environment, it could kill life, animals. So if this is on any sort of chemical, please try not to spill it or throw it down the sink, because that would be also dangerous to the environment. And then this last one is a symbol for oxidizers. That's a Z. Oxidizing, that means it's able to release oxygen, and it could cause a reaction known as combustion, which we will learn later on this year. But it's another fancy word for just flame or making something catch on fire. So again, try not to mess around with any of these symbols. especially oxidizers, just any one of those. Just be aware of these symbols on chemicals because they can cause harm if you're not careful. So there's a couple of rules to follow whenever we go into a lab. One, you'll always be wearing goggles and lab coats, except we don't have lab coats. We will provide you with aprons. Goggles prevent different chemicals or things from coming into your eyes. The aprons prevent the chemicals or anything from spilling on top of your clothes. Sometimes we have gloves, but not necessarily all the time. But for sure, you will have to wear shoes that are closed-toed, so no sandals, nothing with your nice nail polish showing, nothing. You need tennis shoes or anything that has a closed-toed shoe. Okay. Also within the lab, make sure you develop a safe attitude. Always be aware of your surroundings, especially with the big groups of students that we're going to have going in there. Make sure you have a respect for the tools and the equipment. You do not want to throw anything around. If you break something, you will get in trouble, so don't drop anything on the floor or mess around in the lab. Also, you will try to prevent and control any fire. When I mean prevent and control, I mean you will prevent the fire from happening, and if one happens to break out, then I will control it. I will use a fire extinguisher. Also, you need to wear appropriate clothing and protective equipment, just like we talked about over there. And you also need to have a respect for hazardous waste materials and waste. That means you don't assume everything can be poured down the sink. If I don't specifically tell you where to put it, you can ask just to make sure. If it is sink safe, I will also notify you of that. So make sure you always know where to dispose of all your chemicals. And then you will also maintain the lab. That means whenever you go into the lab, look at the station, it will be clean. Whenever you're finished, it should be re-cleaned before you leave. Because we're working in a lab, you're going to be exposed to different types of chemicals or equipment, and you need to be sure or be aware of what they can do if you don't wear any of the protective personal equipment. If you get acids or bases in your eyes, it could definitely cause some damage, if not blindness. Or if you don't wear goggles, if something happens to break or fly off and it gets into your eye, you can also cause yourself to go blind. This is only a few pictures. There are many more pictures of what the chemicals or equipment can actually do to you if you're not careful. So I would advise going to a lab, having that safe environment, be aware of your surroundings, and make sure you don't horseplay. If for some reason you get a lot of the chemicals on your body, all over your body, you will go to the shower and you will pull down on this triangle ring and a massive flow of water will spout out from the top and it will cover you completely with water. So you do not want to use the water shower unless you actually have to. If you get something really small on your body, please go to the sink, wash it off with soap and water, flush it for about 10 to 15 minutes, and you should be okay. If you get something in your eye, we have an eye wash station for that. They are located on the sinks inside the classroom in one specific area, and there's also one or two in the laboratory, and I'll identify those specific locations whenever we get in there. If you get something in your eye, you'll turn on the eye wash station. Water will shoot up from the top, and then you will have your eye over the eye wash, and you're going to flush it out for about 10 to 15 minutes just to make sure you get everything out. And then the last one, this is a fire extinguisher. We have one in the laboratory and in the classroom. This happens, you use this whenever there's a fire that breaks out. I will be the one to use the fire extinguisher. You as a student, you will go away from the fire and I will take care of everything. But we need to be aware of the location just in case I get hurt and then someone else would have to do or work the fire extinguisher. So when scientists try to inquire about something in life, they undergo what is known as the scientific method, in which you first ask a question, then you do some background research to help you understand the subject or the topic of what you want to do an experiment on. You want to construct a plausible hypothesis once you do some research. You will test with an experiment. If it works, you will analyze the data and draw some conclusions. And if your results align with your hypothesis, meaning that they go in line with your hypothesis, you can finalize your paper and communicate your results to the world. However, if your experiment is not working, you need to carefully go back and analyze what you're doing. Do you need to reform a new hypothesis, a new experiment, and then you can try to do that all over again. However, if your results align partially or not at all, then you can go back, restruct a new hypothesis, and then move on. Again, through any experiment, you want to make as many observations as you can with your senses. Sight is going to be one of the most important ones because it's nice to tell whether something is having a color change or if there's any other sort of chemical reaction going on. You can smell the container using the wafting method. Do not put the container directly underneath your nose. You can also touch the outside container. You never want to put your hands inside any of the pieces of equipment that you're working with. You don't want to touch the chemicals, but you can possibly touch the outside to sense if it's getting warmer or colder. And then you can also listen for sound to help you identify what's going on in the reaction. You want to record all data, especially if you perform multiple trials, which is really good in the science world to have different trials, more than one, to help prove that what you're doing is actually happening. It's not just a coincidence of, we did it one time and that makes it right. No, you have to do it more than once to provide accurate results to tell you that this experiment is proving my hypothesis correct. So there's different pieces of lab equipment that you need to become familiar with. The first one, this is a beaker, and this is used to hold large amounts of liquids for storage. You can stir different reactions. You can even put it on a hot plate to heat it up. The next one is a mortar and pestle that is used to grind up solids to make them smaller. The third one is a crucible, and this is used to heat small amounts of solids at very, very high temperatures. Then you have a spatula. This is used to transfer different solid chemicals for weighing or within a reaction. Then you have a Bunsen burner. And then this is used to heat up different containers or just to provide a natural gas flame that is used for heating in a reaction. This next picture is a watch glass, and a watch glass is used as either as a beaker cover, or it can be used to evaporate small amounts of liquid. So if you have a solid product coming out of your reaction and it's within water, you can put that entire mess of your product on the evaporating glass, on your watch glass, and then you can come back the next day and that water will have evaporated off. The next picture, this is a triangle, and this is what you use to support the crucible whenever you're trying to heat it at very, very high temperatures. This next picture is a funnel. A funnel is used to either hold filter paper to separate out solids and liquids, or it can be used in pouring to prevent any spillage from happening. Then you have a triple balance beam, and then this is used to mass out different amounts of your solids or even liquids, but you use this to measure out grams of a solid or grams of your product at the very end. The next piece of equipment, this is a volumetric pipette. This is a volumetric pipette, and this is used to transfer very small amounts of your liquid from one container to another. Then we can go up to a wire mesh, or known as a wire gauze, Gauze. This helps support glassware during heating, such as your beaker. And it's also used to spread the heat of the flame throughout that entire container. Then we go up to your tongs here. This one is specifically known as crucible tongs because it can move a crucible from one location to another. There's also beaker tongs out there and also test tube tongs. So this test tube will be used to transfer the test tube from one location to another. So just be aware of the 3 different types of tongs, but they are used to transfer different pieces of equipment from one location to the next. Okay. Then you have this is your ring stand. A ring stand is used to support different types of equipment for the reaction. So you could have your Bunsen burner on the bottom, then you can have your triangle on top, and then the crucible sitting on top of the triangle, but it's used to hold different pieces of equipment vertically for a chemical reaction. This next one is a burette, and this helps allow different volumes of liquid, very, very small amounts of liquid, into a reaction container, as small as 1 drop going into your reaction container. So if your measurement has to be very precise, you would use a burette. This is important for acid-base chemistry whenever we do titrations. Then we have our graduated cylinder. The graduated cylinder, this is used to measure different amounts of your liquid. There's different sizes of graduated cylinders, so make sure you choose the appropriate one before you start measuring out your liquid. Okay, so I just erased all the other words so I can have a little bit more room to write. But going on to the next picture, this is a wash bottle. And this is used to dispense different amounts of your water, normally used to wash off your equipment, or even add a little bit more water to your reaction. This next picture, this is known as an E-flask or an Erlenmeyer flask. This is a container that temporarily stores different types of liquids. You can also use it to heat, but most of the time it's used to transfer liquids from one location to another. This picture up here, these are your rubber stoppers, and these are used to cap off different pieces of equipment like an E-flask or the round bottom flask, or the round bottom flask, even a really small beaker as well. If you need to store something overnight, you can come back the next day and finish up a reaction. This picture right here, this is your test tube, in which your test tube tongs can transfer the test tube from one location to the next. But a test tube is used for many different reasons. It can be heated, but it still holds different small amounts of your liquids, and it can also be used for a small scale reaction to see what would happen before you move up to a large scale. And then the picture down here, this is your micro spatula, which is used to measure or transfer solids of very, very small quantities. And then this last picture, this is a stir rod. You use it to stir your reaction container. You stir the liquid up. You use this to stir your reaction container. So there are other pieces of equipment that are on the lab equipment handout that I gave you or will give you. So if you didn't get one, please come ask me about it. But make sure you study your lab equipment handout. We will be tested over these pieces of equipment later on this year, and plus it's good to have a knowledge base of all the pieces of equipment. So when I say, hey guys, you need to go get a beaker or you need to go get a graduated cylinder, you know what I'm talking about. So in an experiment, you're going to have to be able to identify the independent variable versus the dependent variable. So the independent variable is the variable that you are testing. You set the parameters, you are in control of that variable. The dependent variable, however, depends on the independent variable. So this guy is going to change based on what the independent variable is. So for example, if you were trying to melt different pieces of chocolate, you would set the size as the independent variable. You could have 5 grams, maybe even 10, maybe even double that to about 20 grams. So the size would be independent because that's what you set. And then the time it takes to melt that size of chocolate would be dependent on the size. So your dependent variable is on your y-axis, then your independent variable will be on your x-axis. So anytime you're trying to make a graph, make sure you have those variables set appropriately. So how does an experiment lead to a law? Well, whenever you undergo the scientific method, you must come up with a hypothesis. So this is a testable statement, which can either be supported or not supported. If it's not supported, you would have to go back and change your hypothesis to be able to answer it correctly. So they always start out with your hypothesis. Okay, so whenever you test that over and over and over and over again, and you are able to support that hypothesis by having correct data or data that helps correlate to answer some sort of question, it would then become a theory. Okay, so unlike hypotheses, a scientific theory is well established, it's highly reliable. However, it may be subject to change as science evolves and you go into the future. More people are going to try and test it to help prove it wrong or prove something else is correct. So a theory is more explained, or it's better explained in the end, but that's after you test the hypothesis over and over and over again. So nothing disproves it; it becomes a theory. Then, if you keep not disproving the theory, it eventually becomes what is known as a scientific law. Okay? And a law is a concise statement that summarizes the results of those many experiments. So as time goes on and people try to disprove the theory, if they can't, again, all of those experiments help come together to summarize the overall underlying concept that's known as a law.